Welcome back. So today we are going to talk about sampling methods, which is basically how to collect data. So throughout the course, I just gave you data, or you looked at data on the web. It was like just given to you. And we did some math with it to draw some conclusions. The problem, of course, up to today is we don't know how the data was collected. And if the data that you collect or observe or interview or survey or call or contact, if it doesn't represent the entire population of interest, then you are literally just wasting your time. So let me explain. Oftentimes, we have a question that we want to address. And maybe you're interested to know how many students in the US, let's say, smoke. Maybe you're interested to talk to athletes. Maybe you have a question that only pertain to men between the age of 18 and 21. Maybe it is about toothpastes and you want to know which one is a good one. Whatever question you have, it is so difficult to basically go through the entire population. So for example, let's say I'm interested to know the proportion of men that smokes in the US. Well, I would assume there is 150 million men in the US. If it's 50-50, I think there is about 300 million people or more. So let's say it's 150. Now, you can't just go out and spend your life asking all men in the US whether or not they smoke. Because number one, it'll take you forever. Number two, it is extremely costly. And number three, even if you succeed to interview every man in the US about smoking, this is why I said the population of interest, whatever the interest is, by the time you finish, the population has changed on you. Does that make sense? What I was just describing now is called a census. A census is actually not a good way to get information. Because on one hand, you could say, well, it cannot get any better. I'll just ask everybody. That's called a census. So that's the good news, supposedly. The bad news is a census is not a good way to get information for the reasons I just mentioned. It is costly. It takes forever. By the time you finish, the population changes on you. Some men would have died. Some men would have grown up. Someone who was 17 and you had no plan of asking, now they are 19 because it's taken you 2 years to interview. Makes sense? So what we want to do is we want to pick a sample. So if this is 160 million people, we probably just want to pick 1,000. It's easy to ask 1,000 people whether or not they smoke. And we want to pick a sample that literally reflects this population. So in our example, this sample cannot have females because you are only interested in males who smoke, right? This sample would not involve, let's say, babies or toddlers because obviously they don't smoke, right? So there are methods on how to pick a sample that is reflective of the entire population of interest. There are methods. It's not clear science. There is some art in it, but you can certainly be objective even within a subjective idea. So I know a lot of people are visual learners, so I drew a couple of pictures for you. This picture and this picture. And because what I'm trying to do here is to get to the idea of how do you pick a good sample, okay? A good sample means a sample that reflects the population. So let's say you have guests come in, and you or your dad or mom made a big bowl of soup. That's your population, the big giant bowl of soup. It'll feed like 20 people. And you took a small bowl or maybe a teaspoon to taste it, right? That's your sample basically. This is like this, and this is like that, okay? Obviously, you don't want to taste from here, right? So you take a sample and you want to get a feel for the texture, for the salt, whether or not it is thick or liquid, does it need anything? I would say this is a very good sample. Why? Because this is a good representation of this whole thing. If this needs salt, I can bet you that this needs salt. If this is salty, I can bet you that this is salty as well. If this looks very, very red, so as this one, I would say this is a good sample, right? Here is a bad sample. Let's say you made a big fruit salad, and it has maybe five type or six type of fruits, strawberries and pineapples and oranges and bananas. And you took a sample. Now, if you're not careful, you may end up just with strawberries. And so if you have strawberries here, while in here you have six type of fruits, that wouldn't qualify as a good sample. Do you see the difference? And by the way, just as a side note, this is like a discrete case, right? In fact, you can separate the 5 or 6 fruits. The liquidity of the soup, that's a continuous situation, isn't it? You cannot separate the pepper from the salt, from the tomatoes, from the spices. It's all mixed in. That's just a side note. Excuse me. So, clearly this is a bad sample unless you are extremely careful how you take a sample. And this is a good sample. And once again, why do we care about sample? Because it's easy to work with a sample. And if the sample is good enough, which means it is reflexive of the population, then I can do the math with this sample, and I can then extrapolate or project or draw conclusions about the entire population with a very high degree of confidence. That's powerful. I can take 1,000 men, so long the sample is reflexive of the population, and I ask them how many of them smoke, and I find out that 400 out of 1,000, let's say, smoke. That's 40%. I can with high confidence say that 40% of the male population in the US smokes, just by looking at a sample of 1,000, under the assumption that this sample is a good sample. A good sample, in quotation marks, it means it represents the population of interest. So this is a good sample, this is a bad sample. So let's get now to the actual methods. So I'll begin with some bad ways of sampling. And a lot of people do this, by the way, especially on TV. They'll say, next time pay attention, they'll say, candidate A is ahead of candidate B by 2 percentage points. This one has 51%, the other one has 49%, with a margin of error of 3%. And underneath, in fine print, it'll says, this is not scientifically done. Okay? So there are some really bad ways to sample. And a lot of people, including in schools, they sample poorly. They do this, right? So you want to do the right thing. So let me share with you. There is more, but I'm just going to share with you 3 ways to sample poorly. And I'm mentioning these 3 ways because they are popular, okay? The first one is a convenient sampling. And I wrote, the one who samples conveniently selects. Excuse me. So let's say you want to know, let me give you an example. Let's say you are interested to know about the food in your school, the cafeteria food. Is it good? Is it bad? I don't know if they charge. If they do charge, is it expensive or not? A convenient way of sampling your school, let's say your school has 1,000 students, a convenient way to do it is just talk to your classmates. They're right next to you. You just ask them, hey, what do you think of the food? Hey, what do you think of the food? Or maybe you just ask your friends. So that's convenient sampling, and that's not gonna, the people you're gonna talk to, they're not gonna represent your school, because they're either your friends, or just the people in your science class, or the people in your dorm, or your neighbors, or whatever that is, right? Or you just happen to be on campus in some building, and out of convenience, you just decided to ask people around you. You don't even know them, but they're next to you. Why not? Or you stand in front of Macy's or JCPenney. Well, JCPenney is going bankrupt anyway. But let's say you stand in front of Macy's and you start asking people what they think of something. And you do it out of convenience. You just stand there and you just ask random people who come out, because it's convenient. It's right there. You don't want to walk. You don't want to go to different neighborhoods. You just stay put and have your coffee and conveniently sample. You can also conveniently choose who to sample. Let's say you're only interested in people who are coming out of Macy's, what they think of clothing there. And maybe because you are 17 years old, maybe you're just going to talk to your age group. Any old person or a very young person that comes out, you're just going to ignore them conveniently, right? That's a very bad way of sampling. Why? Because it will never represent the population of interest. Okay. The second one is voluntary sampling or voluntary response. This is what most TV stations do. So they'll say, hey, we're going to have a debate, and if you agree, call this cell phone number and say yes. If you disagree, say no. You are allowing people to self-select. This is a true story. Many years ago, an anchor on TV asked people, or parents, I should say, older people, whether or not who have had kids, okay, or who have kids, whether or not if they were to push back the clock, will they have the kids again? So let's say I'm a parent, I have a son who's 10 and I have a daughter who's 12, and I'm asked on TV, hey, if I take you back 14 years from ago, right? Well, you had no kids. Knowing what you know right now, would you have kids? And people voluntarily answer the question, yes, I would. No, what a silly question. How could you possibly ask this question? It's like, oh yeah, I would definitely not have kids, So what happens is, on that TV station, they said, okay, well, they gave a high percentage of people that would change their mind about their kids. It's sad, right? Well, then, they got a lot of flack, and so they decided to hire statisticians and to pick a proper sample. We're going to talk about some proper samplings today. And it turned out to be the opposite. That actually most people would never change their mind on the fact that they have kids. What happens with voluntary sampling? This happens all the time in schools. Kids send you surveys and they say, if we just get 15 responses out of 40, that would be good. Well, you're asking people to self-select. The really worst thing about this sampling is people with extreme views are the ones who end up responding. So for that TV station about whether or not you'll have kids again, people who thought that question is out of line did call and say, how dare you even ask that question? And people who are so fed up with their kids, they also called. And all the neutral people in the middle, they just moved on with life. They did not volunteer to respond. So people with extreme views are the ones who end up volunteering for that sample. So that's a bad way to sample. I'll conclude with this one. There is more, okay? Random sampling. And I wrote, what are you talking about? Because like, what do you mean? Random. I am randomly selecting. You know, what could go wrong with this? A lot of things could go wrong with randomness, okay? And this is also abused. You could do this properly, but oftentimes it is abused. I'm going to give you a concrete example. So let's say you're interested to know what people think of the iPhone, okay, in your city. And because you're so aware of these two that are bad, you decided to do something better, right? You think it is better. It turned out to be not better, right? It's like, you know what? I am not going to do it out of convenience. Just ask my people next to me. I am not going to let people choose. I am going to choose people. And I'm going to do it so randomly. I'm going to go to random people on the streets and I'm going to ask them what they think of the iPhone. That sounds good, actually, right? The problem with random sampling is it is very deceiving because you might think you're doing some good. You know, you're doing good. You're doing your homework. You're not letting people volunteer. You're not trying to do it out of convenience. You're trying your best to interview the males, the females, the young, the old, at 10 o'clock, at 10:30, at 11 o'clock, you know, let's say in the morning, Monday morning, right? People you know, people you don't know, people who look angry at you, people who look very happy. You were so good because you randomly selected people. The problem with this method is you are completely ignoring an entire portion of the population called workers. So go back here. So a lot of people on Monday at 10:30 in the morning, like maybe half of this, or maybe more, are at work. They're in the office. They're not gonna be on the streets for you to ask them. Does that make sense? Another example would be, probably even clearer example. Many years ago, you're too young to know, but you know, like in the 80s, the post office would drop a big yellow book in front of people's homes. So it's called the Yellow Pages. And what is it? Is all the phone numbers of the people that live in your city. They are businesses and individuals. So I would flip the page. I would chronologically look for my last name, and my name is right there with my phone number. That's how it used to be done. And let's say you say, you know what? I'm going to sample my city about some question. And you take the Yellow Pages and you randomly open the pages. Like, okay, I didn't choose. I am randomly picking page 521. Okay, open 521. And then 521 has 100 names. So then you're going to close your eyes and you will randomly pick a person. It's like, okay, see, I did it right. This person, I had no say in it. So I'm going to call this person and see what they think of whatever you're interested in. The problem with this idea of randomness here is you're also ignoring a big part of the population of interest. For example, a lot of poor people at the time didn't have phones. And if they don't have phones, they're not in the Yellow Pages. And therefore, there is no way you're going to contact them. Another portion of the population that you're going to be completely ignoring is very, very, let's say, you could say wealthy, or you could just say, well-known people like actors. They actually pay, so their number is not published in the Yellow Pages. Now you're ignoring another portion of the population. So even though your intention is right, and you are trying to be fair, you simply ignored maybe 3/4 or a quarter of the population of interest called the people in that city. There are a lot of people who are poor, that they don't have home phones, landline at that time. There was no cell phone, so everybody had landline. And then you have some very, actors and presidents and just wealthy individuals who could care less to have. In fact, they don't want their phone number to be in the yellow pages because people will bother them, right? So I'm gonna say that random leads to bias. Half an hour ago, you wouldn't have agreed to this. Randomness does lead to bias. Bias in mathematics is when you systematically favor an outcome over another. It's not the bias that you think of. Oh yeah, she was so biased. She told me my teacher gave me 80, but he gave her 79, and we had the same answer. My teacher was biased. That's not what we mean by bias. Bias is when you systematically favor an outcome over another. So if I always give you a higher grade than her, and you have the same paper, that might qualify as bias, right? So just because there is a little difference, that doesn't lead to bias. But in any case, randomness leads to bias. So these are 3 bad ways to sample. So these 3 ways, think of this, right? Think of bad way to sample. So let's talk about some good ways, and then I'll stop. Some good sampling methods. The most basic, and what I mean by basic, it doesn't mean it's silly. It just means the rest, there is more. There is at least 5. I only did 3. Most of these are based on the first one. That's what I mean by most basic. It is powerful, but you build this on this, and you build this on this, and you build systematic sampling, which I didn't discuss, on that as well, okay? This is called simple random sample. Now, you see the word random there. This has nothing to do with this, okay? So when you see random sampling, bad. When you see simple random sample, that's good. What does this mean? It means every member of the population has an equal chance of being picked. So for example, let's say you want to take 10 representatives from your school. And the question at hand has nothing to do with gender or anything. You just want to pick 10 out of, let's say, 1,000. Well, now, every member has this much chance of being picked. True or false? What's my chance of being picked if I was a student in this school? 1 in 1,000. Now, let me show you one way to do it properly and one way not to do it properly. So I picked the first one. Let's call him John. John is picked. Done. So now I have 9 left. So now when I go back to pick, now I only have 999. True or false? So now everyone has an equal chance of being picked from 999. So that probability is 1 over 9999. Oh, I said 4 times, sorry. See how the probability changes? We don't like it. So that doesn't fulfill this condition. Every member of the population has an equal chance of being picked. So what I would do instead, I picked John, didn't I? We're going to put John back in the pool. So I have John here still. We know we picked John, but he's back in the pool. Now I still have 1,000. Then I'll pick a new one. Everyone has an equal chance of being picked. 1 out of 1,000. Then I end up picking Jane. Then I put Jane back. I still have 1,000. Let's say third time I pick John again. Oh, well, you just repeat. Put John back and start over again, right? Until you pick 10 of them. John, Jane, Jody, whatever. Okay? So that's the idea of a simple random sample. Everyone has an equal chance of being picked. And as you can tell from bad samplings, not everyone has an equal chance of being picked. On the yellow pages I gave you, or you're interviewing people at 10:30 in the morning, you're ignoring all the people in the office who are working, right? Voluntary, not everybody has an equal chance, because only people with extreme views are going to call you, and the people in the middle, they don't care. They'll just move on with life. Or mathematicians, by the way. They will never respond because they know this is a bad way to sample. I wasn't listening to that what is it called? That piece of news. But if I was, I would never call because I know it's boring, it's stupid. No matter what they do, it's not a good sample. Same thing here. When you conveniently talk to people, you're ignoring all the people who are not as convenience. So not everybody has an equal chance of being picked. Okay? So that's the idea. Okay? And there are ways to do it on your graphing calculator, which I'm not going to go over, or like in some stats book, they have numbers, and you pick a row, and you pick people randomly. Okay, so this is called simple random sample. Now, stratified sample is a stratified simple random sample. So what does that mean? It is still an SRS. It is still a simple random sample, but with stratas. So let's say at your school, let's say you want to select a board. You want to select a board, and basically you want to pick a president. You want to pick president, vice president, secretary, and then what do we call the fourth one? My goodness, it skipped my mind. President, vice president, secretary, and oh my goodness, it skipped my mind. The one who deals with money. It'll come to me. Fourth one, fourth person. Okay. Now your school has 1,000 students, but it happens to have 250, let's say, males, and 750 females, let's say. Okay, this is almost unusual, but just for the sake of arguments. All right. So you want to pick 4 people to represent your school. Well, you could do a simple random sample on 1,000, right? Everybody has an equal chance of being picked. This is the probability of being picked. You pick the first one. You put them back in the pool, like I did with Jane and John. And you pick the second one. And then you put them back in pool, and you pick third one. And that's fine. You could take a sample of 100. And you choose your 4. But that's problematic, even though you're trying to have an equal chance of being picked. The problem is you have a lot more females than males. So what you may want to do instead, I mean, would it be fair if I have male, female, male? Would that be fair? Even if I use a simple random sample. Would it be fair to have 2 females and 2 males, right? I would say, because I have a lot more females, in fact, 3/4 are females and 1/4 are male, I would stratify it by gender, split it by gender first. Then out of these 250 males, use a simple random sample to pick 1. And out of these 750 females, use another simple random sample. Let's call it simple random sample 2, simple random sample 1. And from this 750, you pick 3. This way you end up with 3 females and 1 male. I still use the simple random sample. Don't get me wrong. But first, I put my student in stratas. Strata is the plural. Strata by gender. I split them by gender because I have such a difference. Now, it doesn't have to be gender. Maybe you have 500 seniors and only 200 juniors and 200 sophomores and 100 freshmen. And let's say we don't even choose freshmen, right? Because these are like, they represent school and we ask that they are older. Let's say we only ask for these 2. That's the policy of the school. Well, you can't just pick a simple random sample of 700. You may want to split them between seniors and juniors. Look at these proportions, and maybe you'll have a lot more seniors. Maybe you'll have 3 seniors and 1 junior. Does that make sense? So you don't always stratify it by gender. Sometimes we stratify by other things, if we know that those things will make a difference. All right, I'm going to conclude with cluster sampling. So let's say your states, I'm going to pick on Texas. Let's say your states or the Board of Education in Texas is very interested to know what seniors think about something. Seniors only, okay? Now, there are a lot of seniors in Texas. So using a simple random sample is not necessarily a good idea at first. You may want to do something else, like we stratified first before we did simple random sample. We may want to do something first before we use a simple random sample. This is the building block. Remember, everything is built based on the simple random sample. So what you might want to do is say, okay, let's say in Texas, there are 16 cities, right? So we're going to take all schools within each city, City 1, City 2. I should have given them names. Dallas, Houston, Austin, and so on and so forth, right? You may want to split them by cities first. And maybe there are 16, I don't know how many cities are in Texas, but let's say there are 16 of them, okay? And put every university in that city in that little cluster. Maybe there are 10 universities, put them in here. In the city of Dallas, maybe there are 23 colleges and universities, dump them there. Put them in clusters. Now, these clusters, they all look similar in a sense that they have freshmen, sophomores, juniors, seniors. Freshmen, sophomores, juniors, seniors. They look similar externally. They have males and females, right? They look similar externally. However, internally, let's pick on Dallas, they have males, they have females, they have freshmen, they have sophomores, they have juniors, they have seniors, right? So they are mixed within each cluster. They all have the same thing, right? Male, female, freshman, and so on and so forth. They are non-homogeneous within each cluster, but across clusters, they look similar. Then what you do is use a simple random sample out of these 16 cities. Use a simple random sample to pick one. So let's say we selected Austin. Now you go to Austin, and all the universities are here, remember. And you then interview every single senior, because you were interested in a question with seniors, right? So in the city of Austin, you group all of those colleges there, and you just ask every single, you don't do a simple random sample anymore. You just ask every single senior, every one of them. Notice that these seniors plus these seniors plus these seniors plus these seniors plus these seniors are all the seniors in Texas, aren't they? So let's say Texas has 10,000 seniors. Well, if you split them by city and put all the colleges in that city within that city, then all the seniors will be a combination of these seniors in here. True or false? That's key for cluster sampling. And then once you use a simple random sample to pick a particular city, and I just picked on Austin now, then you go to every senior and then you ask your question. It's almost like doing a census on every senior. You ignore these altogether now. Make sense? That is called cluster sampling. Divide the population into groups. In my case, I call them cities. Then with an SRS, pick one cluster. So using an SRS of 16 cities, I picked one cluster called Austin. Then what? Then interview or a survey or whatever, survey every member of interest. In our case was seniors. If it was females, then you just talk to every female in Austin, in that cluster of universities in Austin. If you're interested in freshmen, you do the same thing. But you do a simple random sample on 16 cities or 16 clusters to pick one cluster. We decided on Austin. Make sense? All right. So I am going to end here and conclude with an assignment. And I really would love for you to have fun with this. Maybe you'll go back to your school. Your school will be very happy with you. So I would like you to think about your school. You all go to a school, so think about your school. And I would like you to think about something you are curious about at your school, something that bothers you, something you want to improve on, you want your school to improve on, something that you're curious about. For example, maybe the line is too long in the cafeteria. Every time you go out for lunch, the line is too long. Maybe that's something that bothers you because you want to solve that problem. Okay? I don't know what is the issue. Maybe the schedule. Basically, you want to interview or survey or you want to contact a sample of people within your school to get some information to solve the problem. Right? So what I would like you to do is to devise a detailed plan. Don't just say, I'm just going to talk to the... No. I want you to write down exactly how you plan to tackle that issue. What sampling method will you use and why? Okay? How you will properly sample to address the issue at hand. Okay? So for example, the idea of the line in the cafeteria just kills me. Every time I go out, it's too long. And maybe your school has 1,000 students. I don't know. So you want to pick a sample. Okay, so clearly you're going to ignore these. You're going to pick a sample and you're going to say, okay, how do I pick a sample that represents the entire population of interest? It doesn't have to represent the 1,000 students. If your question only deals with seniors, your population is the seniors. Does that make sense? And therefore you ignore the freshmen and the sophomores and the juniors. It's not because you want to ignore them, because the question does not interest them. It has nothing to do with them. Maybe it's something about your athletics, and you want to interview students who plays athletics. Clearly, your population of interest would be the athletes. It wouldn't be the whole school. It would be just the athletes. Well, maybe there are 600 athletes. How are you going to pick a sample? Okay? So, and think of this as a start to something you will pursue when you go back to your school. So you do this for the class, and I'll give you feedback, and then you take it and you go to your school and continue to work on it, and hopefully you'll solve a problem at your school. All right, enough said. Take care.